Imagine a future where living to 150 isn't just a dream, but a reality. Could it happen? What does science say about the possibilities of extreme longevity, and more importantly, would we want it? For centuries, the human lifespan was limited by infectious diseases, malnutrition, and lack of medical knowledge. In the early 1900s, the average life expectancy was only about 30 to 40 years. But thanks to modern medicine, public health advances, and better living conditions, people today live much longer into their 70s, 80s, and beyond. But can we push the boundaries even further? Could we double that and live to 150? And how close are we to achieving it? To understand if we can live longer, we need to first understand why we age. Aging is a complex biological process driven by things like DNA damage, the shortening of telomeres, those protective caps on our chromosomes, and the accumulation of senescent cells, or zombie cells, which no longer function properly. Scientists have been studying these mechanisms to not only slow down aging, but potentially reverse it. But how far have they really come? Recent advances in fields like genetic engineering, regenerative medicine, and artificial intelligence have opened up new possibilities for life extension. For example, researchers are looking into therapies like senolytics drugs that target and destroy those zombie cells, which can improve health and longevity in lab animals. In animal studies, these treatments have shown promise in extending healthy lifespan by as much as 30%. But what about humans? One important aspect of longevity research is not just how long we live, but how well we live. Researchers focus on extending health span, the number of years we live in good health, free from diseases like Alzheimer's, cancer, and heart disease. If we do manage to reach 150, the goal is to maintain a high quality of life during those extra decades, not just add years of frailty. One of the most promising technologies in this field is gene therapy, particularly CRISPR, a tool that allows us to edit genes with precision. By modifying the genes that control aging, scientists are exploring whether we can prevent age-related diseases or even slow down the biological clock itself. This type of genetic intervention could radically change how long we live, but the ethical and technical hurdles remain significant. Tech giants like Google and their Calico labs, alongside numerous longevity startups, are investing billions into cracking the code of aging. These companies are pushing the limits of what's possible with cutting-edge research on regenerative medicine, AI, and personalized health interventions. But despite the excitement, we're still far from a clear path to 150 years of life. It's not all about futuristic science, though. The basics of healthy living still matter. Exercise, a balanced diet, mental well-being, and sleep all play a significant role in how we age. Blue zones regions where people commonly live past 100 show us that lifestyle choices can make a huge difference. Will combining these time-tested habits with cutting-edge science lead to breakthroughs in longevity? But even if we could live to 150, should we? There are major ethical questions. How would it affect overpopulation, resource use, and the planet? Would it widen the gap between the rich, who can afford life-extending technologies, and everyone else? Some argue that extreme longevity could lead to societal challenges we haven't yet faced, from economic strain to environmental impact. So, can we really live to 150? The science is moving quickly, and breakthroughs in genetics, medicine, and technology are bringing us closer to that possibility. But whether we reach that milestone physically, ethically, and socially remains an open question. One thing is certain: the future of longevity is an exciting frontier, and we're just beginning to explore what's possible. If you enjoyed this video, don't forget to like, share, and subscribe for more content about the future of health, science, and longevity. Thanks for watching.